All right, good evening, everyone. Welcome to another day of KodeCamp DevOps class. This is an introduction to Git, and like you all know, like we mentioned, this is like a foundational training. This is the most foundational training that you will go across. So you have to, this is the first step to understanding whatever you need to do as DevOps engineer, Git. Git is introductory and it's not really something that will take time explaining, doing a lot of explanations. Today we'll just focus on the whole, talking about the Git, what Git is and everything. And then we'll go over to GitHub because, like I said, we'll look through the ecosystem of GitHub. GitHub is what we're focusing on. This period, like in this part of the class. Then on Friday, which is our second class, we'll go hands-on doing stuff with Git so that for those of you who may have issues with your tasks, you would attend the hands-on and get familiar with the Git ecosystem. Yeah. So any questions so far? See me, I'm asking it for questions. Let's proceed. Don't mind me. So yeah, what is Git? Now, Git is a distributed version control system that allows developers to communicate on a project efficiently. It enables tracking changes in source code, coordinating work among team members, and maintaining a history of modifications. What do I mean by this? As in a DevOps environment, you are most likely going to work with multiple people. You are most likely going to work in multiple environments where you would have to, where you have to collaborate basically. Git is the single, so what I call it, what they call a single source of truth where this collaboration will occur. For example, um, I build a particular code. Your developers build a particular code. They want to track the changes to the code. They want to roll back to a previous version of the code if the one that they work with currently does not work. They want to just generally make changes. For example, they want to store the code in a repository, which is GitHub. Now, this whole thing, everything you're doing all boils down to proper knowledge of Git. Now, previously, before the introduction of Git, people work in silos, which is what I explained in the first class. There was this silo where you write your own code. For example, you write a code to the front end. You now probably put your code in a flash drive or a storage system and send it to the backend person that will write backend code. Then probably send it to the IT team that will now copy the code from your flash drive to the server, or run a secure copy from your local disk to the server, which is not sustainable. You find out that even if you make mistakes in the code, or even if you need to change the particular working version, there are situations where you would make a change and then it does not work, but you cannot track the change. You cannot know what exactly you did that made it fail. This whole issue is solved by Git. Now, once you integrate Git into your code base, basically, what you need to do is whenever you make a change, for every little change you make to that repository, to that code rather, it tracks the change and stores it. You will see if you will see your particular file. If you're using environments like Visual Studio Code to write the code, or let's say your developers give you the code. Let me use that example. Your developers give you the code. You will see all the particular changes they make that they make to the code, and you can be able to track. So for a situation where you're trying to deploy and it does not work, you can easily roll back. You can easily point them to the previous change and then roll back to that change. That whole setup is managed by what we call Git. Yeah, so let's move forward. How Git differs from um how Git differs from various controls. Now, Git is not the only version control system, but it's the most popular version control system because of the following models. Yeah, version control model. Now, when I say version control, that's the whole concept around Git, version control. You get each new change you introduce to your code, it involves a new version. It's saved as a new version. That's why you can easily roll back to an older version. You get, if you want to make more changes, it's a newer version, like that. You keep on doing that till you get till the code is properly deployed. As a DevOps engineer, yes, it also works for deployment as well. You may deploy a particular version of a code. You may deploy a particular version of a code, and then it does not work. You have to roll back to the previous version. You have to revert back to the previous version, which, yeah, so when you revert back, then you deploy that previous version and keep it first while your developers or you will be working on fixing this newer version. So yeah, the feature is version control model. Each developer has a full copy of the repository, enabling offline work and reducing reliance on a central server. This simply means that all your developers have a full copy of the repository. When the code is deployed to a repository, all the developers have their own copy, and they easily make changes to the repository, basic stuff. Then other version control system is more centralized, and developers must be online to access or commit changes. Then performance efficiency. Git is designed to handle large projects efficiently with fast commit, branch, and merge operations. We'll talk about these following operations while we are learning this. Like I said, today we'll do more. This Git now we'll talk basically on the theoretical part, everything theory. On Friday, we're going straight to the hands-on where you see how everything works. We'll have a sample code. I'll provide sample code. We'll add stuff on the code and you see the code change. We'll add stuff on the code and we'll see the code change. We'll revert, we'll do all the Git setup. So I just want to understand this. Now, slower performance for version control systems, often less with large projects due to central server dependencies and heavier operations. Then branching and merging. Developers can create and switch branches easily and quickly, encouraging experimentation without disrupting the main code base. Slower branching for other version control systems. Branching can be slower and more cumbersome in centralized systems, making experimentation harder. Data integrity. There is SHA-1 hashing, where every commit and file is checksum with a SHA-1 hash. We will get to see it during the answer, ensuring data integrity and making tampering easily detectable. Then lesser integrity. Centralized version control systems may not offer the same level of file integrity, relying more on central server backups and system stability. You can screenshot this if you want to refer to it, or when the video comes out on YouTube, you can easily reference, but this is just the theory basically. Now, these are the core concepts of Git. Repository, you hear repository. These are the concepts. Now, the first concept is local repository. The local repository is the version of the project stored on the developer's local machine, which is your local machine. Because I'm always using developer because it's DevOps, you get basically. But you are the DevOps engineer. You will most likely be given a project where, oh, the front end has worked on it, the back end has worked on their part. It's now left for you to now deploy, to run the automated testing and deployment. So you will have your own copy in what they call your local repository, which is a folder, which is the folder on your laptop, the folder on your machine, you get. Then here, developers can make changes, commit updates, and manage branches without needing internet connection. Here you'd, like I said, just like basically writing your code, basically, running tests and running manual tests, basically. Just get that feel to just, test the system locally before you deploy. Now, remote repository. This is a version of the repository stored on a remote server, which is GitHub, GitLab, and Bitbucket. It enables collaboration and backup of the projects. Now, looking at this setup now, if you look at this diagram, this is basically what a setup does. This is basically what the Git setup does for you. Now, this is your workspace. I don't know if you can see where my mouse is. This is your workspace. Then once you do the command to add, it adds your project to what they call an index. Now, this index now, it's like what I call it, it's like an environment that holds the code, but it's not yet pushed to the local repository. But it's when you commit, it is when you make the commit that it is now stored in the local repository. So you can make multiple changes to the file goes to the index. Multiple changes goes to the index. Then when you commit, it's now stored as a local repository. So in the local repository now, that is a copy of your code. Well tested, well put together, and ready to push to the remote repository, which is GitHub. Now, when you, like, for example, now you have a code, you're finished writing all the, probably you're finished creating all the things you need to create. This is what they call a staging section. You now stage it. You get, once you stage it, it's just basically like terminologies though. Once you stage it, you now commit. So the committing now is what now makes this local repository. Everything will still be within that project folder. Now, when it is pushed to the local repository, which is GitHub, and probably developer A, developer B, developer C makes any change to this remote repository, you can now fetch the new changes into your local repository. I'll show you how it works. Like I said, you can now fetch the new changes into the local repository. Once you fetch the new changes, your project structure will change. For example, if what is in your local repository is a.html, for example, once you push a.html to your remote repository and another developer comes and puts b.html, c.html, d.html in the remote repository, mind you, like I said before, the remote repository has all the developers and everybody has access to it. They can make changes and pull everything. Once you do a fetch command, those extra changes, which is the b, c, and d.html, will be pulled to your local repository. So as a DevOps engineer, you get basically, this is what makes you a DevOps engineer, because for every change a developer makes, you push it, you do all the testing, you do all the local testing, then you also push as well. So it's when you put, now the developers will do all their changes, basically all the necessary changes, and then you fetch, you do your testing and the rest, then you push. Once you push, yeah, your own pushing is probably like the final, because you are at the end of the food chain, basically. They will do all they need to do. Then you now push. This is your push now that will now like trigger the build. That's what we'll talk about. I don't want to talk big talk. Now, this when you fetch, you put to local repository. Now, you can see checkout. This checkout now, checkout takes the code in the local repository. You can pull it out. For example, now there's particular folder in your local repository, but you want to remove it. You want to remove it, you want to revert. So you run a revert command to remove that particular folder from your local repository back to your work. So that folder will not be part of what will be put to the local repository. I don't know if now diff is also similar. Yeah. I feel like I'm talking too much. Well, when we get to the hands-on, we'll understand it better. Now, commit. Now there's a staging, commit message, and commit history. Now, like I mentioned before, staging area is a place where changes are prepared before committing. Then the git add command adds files to the staging area. Yeah. Then commit message. Now, for every commit you want to commit to a local repository from the staging area, which is the index, like I mentioned in the last one, you have to tag it. You get you must tag it, which is the commit message. So, for example, you are a developer. I'm always using developer because it's DevOps again. You're a developer or you're a DevOps engineer that wants to make a change. But the last change that was made is probably you fixed the home page, for example. Let's say you're deploying the front-end code. And the last change that was made was a fix to the home page. That is what you write on your commit message. Fix, added whole new homepage feature, or fix, added a new color to the header. You get, hold on. So sorry, I had a bit of an interruption. So as I was saying, yeah, the commit message for every new fix that you make, you have to tag it. So if you're also deploying as well, people will also know, because like I said, it's promoting a collaborative environment. Commit messages are very important, and the way you structure your commit messages too are also as important, so that you don't get to make mistakes, you get to carry everybody along, basically. You can't just go and start writing what you like there. But it is limited to your company. You get, it's limited to your company and what they approve as commitments, because there's some companies that your commit message must follow a particular pattern. You get, that's just by the way, basically. Then there's commit history. Commit history is a log of all the commits made in a local repository, which is the git log with git log command displays the commit history. Now, you can see here what there's working directory. When you run git stage, it takes the code that is in your working directory to the staging area. Now, from this staging area, you can check what is in the staging area with git status. Now, if you have 4 files in your working directory, you move it to the staging area. You can now check. Git status will show you this staging area and show you what the 4 files that you just put inside here. Then, if you now want to commit to a local repository, create a local repository from your folder, you do a git commit. Now, a git commit, you have to do a git commit message show you. So if you're using git commit, you would do git commit -m then with a message, or when you do git commit, to show you like an interface where you write the message, which is I made a fix to the home page, and then you basically the repository is created. Yeah, then git log commit. Now git log shows you the commit history, basically all the commits that you have made to that particular repository. Now git init basically is the start of everything that you want to create. Now, for example, now a developer will not give you a new code without git, but let's say, for instance, you are the one starting the project from scratch. Git init creates that git repository, local git repository in your code. Yeah, so that's just it basically. So branches. The next concept we're going to look at is branches. Now, what is a branch? A branch in Git represents an independent line of development, which is the most simplest answer I've ever seen. It allows multiple developers to work on different features without interfering with each other. Now, creating a branch, you do a command, git branch, feature branch. Let's just say the name is feature branch. Then git checkout feature branch or git switch feature branch. To merge branches, you do git merge feature branch. Merge integrates changes from one branch to another, typically bringing feature development into the main branch. This is basically self-explanatory. So when somebody tells you to create a branch, now there will always be a main branch, which is a master branch, but they don't call it master branch anymore. They call it main branch. I'm just letting you know. The main branch is the branch that goes straight to production most times. Yeah. But in a situation where you want to make a change, probably the client has said, I'm talking as a developer basically. Probably the client has said, they don't want this color. They want red. You cannot go and modify a main branch. Now, as a DevOps engineer, there will always be situations where you would need to probably run tests, but you will not run tests in a main branch. You always have to create a new branch to run your test. For example, now you'll be asked to integrate automated testing. You will not go and create automated testing on a main branch. You have to create it on a new branch. Now, a new branch is like an extension. So it will take what is in the main branch and create like a new chapter for you, where you will do all your iterations, you do all your testing, you do all the failures, basically, just like in class, sometimes they'll always tell you, don't solve on your answer sheet or don't solve on your question paper or something. Carry a separate paper and do all your rough work. So that's what a branch basically does. So you have to create a new branch and do all your stuff there. Then once it's approved, most likely you are the DevOps engineer. Once your test pass or once everything pass, then you merge it into the main branch. Now, all these things happen both in a local repository and in a remote repository. In the remote repository, this is the point where the main branch is what now gets deployed. So they don't deploy a feature branch. It's never deployed. What is deployed is the main branch. This is the main branch that when you deploy and probably something fails. Now, most people may probably miss something. Most people may probably miss something while deploying. You get. So what you do is once the deployment fails and you roll back to a previous version that's working, you tell your developer, please create a new branch and fix these changes so that once it's merged, the deployment will come through. Now, this is what they do. If you're a developer yourself, you once the deployment has failed for whatever reason, to find out the issue, you don't find out issues or you don't debug, you don't troubleshoot on the main branch, on the master branch. You create a new branch, identify the issue and fix it. So once it is fixed and it is working, you merge to the main branch. It's like you know all these roads that are straight roads, then they are like other side roads leading to right and leading to left to get some stuff done. Once it's done, you come out of, for example, now you're on the express and you see a road going to the right to a supermarket. Once you get to the supermarket, you buy your stuff, you come back and you enter back into the road, basically. That's how the whole concept of branching works. Keynotes. I know that most people, I know one question I'm going to expect, oh, why are you talking about developers? Why are you talking about developers? You will always work with developers. That's just the simple truth. As a DevOps engineer, you will always work. And even if you don't know how to write the code, it is always best that you must learn terminologies so that they will not mess you up. You get? It is ideal, like I always said the last time, to learn a bit of it. But even if you don't know it, you can easily tell the developer, already the deployment fails. You can tell the developer, please create a new branch and fix these changes so that I will merge it and deploy. That's your work as a developer. If you just gonna tell them fix it, they won't really take it serious because it does not know anything. But now that you understand, that's what I'm always saying as a developer, because now you're putting on the cap of a developer because it's DevOps, but you're not necessarily writing code, basically. So yeah, I hope everybody is getting it. Do I need to roll back to something or? I hope everybody is getting it. Please, can someone unmute your mic and just give me feedback real quick before I continue?
So we're getting it big.
I know that you people will say, like I said, that's why I want to
Please,
I
so
want to
this
break.
branch, if you can take this branch again, I will be grateful.
Okay,
It's already
okay.
branching ahead like this.
You say what? I didn't hear you.
I said it's already branching my head like this.
No. Okay, I don't know. That's why I said that is the reason. This is the reason why I didn't want to do hands-on today. You get? I want to tackle everything theoretical so we understand it. You understand? Now, let me say a branch. Now, in a on a code base, there will always be a master branch. That master branch is what is getting deployed to your server. You get? Now, when there's need for changes to be made, you will not make changes on a master branch. Just like in a situation where, just like in a situation where you are trying to write an exam, a sensitive exam, but you cannot go and be solving on your question paper or your answer sheet. They will always tell you, carry an extra sheet of paper that you will solve on top. Then the answer, when you have gotten the answer, you move it to your answer sheet. Do you understand that concept, the way I explained it? Can somebody answer, please?
Yes.
Yes,
sir.
Karen, do you understand that concept?
yes,
Hi,
I
Karen,
do.
do you understand that? Good. Now that
I
is what
understand this. Like
good.
it's
That's what
exponential.
good. That's what branching is basically. In a software development lifecycle, you don't modify the main branch. The main branch is like the golden child of the code base. That's the child that goes straight to the server. Now, what branching, that's why people adopt Git, because previously you see multiple hands will be touching, just like the popular Nigerian saying, I don't want to speak pidgin here because of people that may not be familiar, but the popular Nigerian saying that say too much hands on the soup will spoil it. You get when multiple people are cooking a pot of soup, the soup will never turn out good. You get. So that is what branching is, basically. What branching is that I need to make a change to the code base, yeah? I need to make a change to the code base. I make a branch from the already existing main branch. I can call it a future branch or a bug fix branch. You get? Now I will do all my testing on that branch, all my troubleshooting on that new branch, all my error finding, error, kini, every mistake, every finding I want to do for that issue that I just found on the new branch until it is solved. Once it is solved, tested, and the test has passed, I will carry that new changes and merge to the main branch. So the main branch now will have your new change that is working appended to it. And that's what will go to be deployed. Do you understand? Hello, Karen.
Yes, sir. Yeah, I do.
Do you people, does anybody else understand? The person that told me talk about branching again, do you understand it?
Yes, we understand, sir.
Good. In a nutshell, you don't modify the main branch. It's a taboo anywhere in the world. You don't modify the main branch. You make changes, you move the feature branch, make it, and then merge. Once you merge, the main branch must always be a branch that is working. Then sometimes, you know how sometimes you may miss one or two things, or you may miss some configurations, it may fail in deployment. Then you make okay, I will not say the main branch must be a branch that is working. The main branch must be a branch that you are sure it is working. Because you being sure it is working doesn't mean it's working, but it's something that is like a final product, a final finished code. Then when you deploy and it does not work, because it could happen, then you now roll back. Get in, see, you can have almost, you can, in a code base, let me just give you the heads up now. In a code base, you can have almost 100 branches. Not just these things I'm showing you here. That 100 branches involves around different changes you have made over the last couple of the time of the project. So, but there will always be one main branch. That's the main golden child of the code base. So yeah, I guess we understand now. Moving forward.
Okay, sorry, sir. Hello,
Now,
sir.
yeah.
Can I ask? Okay, so sorry, I kind of joined this, but is there a connection between the main branch and the staging area?
Staging
Do you get my
area.
question? Yeah, and the
Yeah.
main branch. I don't know. Okay. Because I checked
So
the flow chart, I can't see anything like branch on the flow chart for the
no,
staging area.
staging area is within your local repository. So everything, now when you create a branch, then your new branch will also have that staging area. You get, we also have the whole staging area commit, all those ones, but you're committing to your branch. Don't worry. I think when we do
Alright.
hands-on on Friday, we'll get to understand. You commit. So when you create a branch is like a copy of your own. Then you do all those staging area commits, all those ones. Then
Okay.
once is now when you push to the remote repository, and it let me say it works, and you push the remote repository, that is to now merge to the main branch in the remote to merge in the remote repository. That's on GitHub. You get, by that one is probably your engineering manager, that's the person that is managing the project or something, that will now do that merge because it's not you, or it may be you depending on your experience. Then once the person has approved it, it's now you that will now deploy the code, basically. But it depends on your, they can hand the merge process to you. It might be a manager that will oversee that, ensure that everything is working. And when it's approved, it's now you that they will give, okay, the branch has been merged. Let us now deploy the code. That's your work now. So yeah. Now, cherry picking. These are more advanced concepts. So cherry picking is like it's a powerful DevOps command that allows developers. Now, this concept is more as a bit advanced. And don't just look at it because it's simple, it's explained here. It's a bit technical until, like I said, we'll show you, we'll do all the hands-on. Cherry picking is a powerful command that allows developers to apply a specific commit from one branch to another without merging the entire branch. It's useful when you need to pick individual changes instead of integrating all commits from another branch. When to use cherry picking, selective bug fixes. Now, there are some fixes that you don't want, you want to particularly pick. That bug is in a, it's in your main branch, but the bug is in a particular branch, probably the branch has not been meant to main, but you want to pick out that bug and just add that particular change to the main branch without adding your entire feature branch to the main branch. I don't know. This thing sounds like French. And without adding, so you create a new feature branch instead of making all the change and then merging the feature branch. You probably want to continue working on the feature branch, but you want to still make some changes to the main branch. That's what cherry picking does. Please, I'm begging. I don't know what to say. I'm trying to break it down in the most simple way. That's what cherry picking does. Now, it is not always obtainable, but sometimes in some complex projects, you may have three different, what they call it, three different changes you need to make on a particular branch, or three different bug fixes. But there's one particular one that is the most urgent that the client will want to implement, like want to use na. You get, that is where cherry picking occurs. So you fix it, and then you will merge that particular change to the main or to the master, but your branch is still with, so it's not the entire branch that you merged, it is that particular change you merged. But it is very sensitive because if you don't get the alignment properly, you can spoil the code base, which is why it's an advanced concept, because it's very, very sensitive. It's one thing about Git, if you joins your Git setup, you have joins the entire code base. That's the reason why we want to attack this particular concept first, because this is the most foundational of fun. Because tell me why you could be a DevOps engineer, but you cannot do basic Git operations. So this is why we have introduced Git first as the first class of this session. So yeah, that's the whole concept around cherry picking. Now, there's Git stash, Git copy. Now, temporary storage. Now, these are advanced concepts. Git commit and Git branch are not really advanced. It's mostly Git stash, which we may look at or we may not look at. Like I said, I'm not trying to do anything advanced in this class. This class is for core beginners. So once I just see that, oh, you are getting confused with particular part, that's why we made the timetable to align to anything beginners. You build from there. Temporary storage, Git stash, yes. Git commit does not create the temporary storage. It's more permanent. Then Git branch is it saves on uncommitted changes. That's for Git stash, basically. Clears the working directory, it's reusable and part of commit history. Recommended for switching tasks. Yes, so yeah, basically. I should have put this before that one. So what is Git stash? I'm sorry about that. That's an error from my end. Git stash allows you to temporarily save your changes without committing them. This is also another advanced concept. you can temporarily save your changes without committing them. It's useful when you need to switch branches or pull updates, but you don't want to commit incomplete work. Stash changes can be retrieved later and applied when needed. Now, why use Git stash? Git stash switches branches safely. Now, temporary store changes and switch branch without committing. It keeps work in progress, avoids committing unfinished work just to change context, prevents conflict, and you can work on urgent tasks. Now, let me explain this part. There are some situations where, like I said, I'm explaining as a developer. There are situations where you would be working on a particular branch. You get working on a particular change in a branch. Then someone may say create a new branch to fix another issue. But one thing with Git, for those that are familiar with Git, you can't leave from one branch to another without actually staging what you have changed. But most times you don't want to stage it at that point before you leave. You just probably want to attend to a new branch urgently. That is what you have to be able to use Git stash. So instead of using, staging it to the staging repository, you use Git stash to store it. Then you move to the other repository, fix whatever you want to fix, and then you come back. So instead of just creating half changes in your staging area, you just stash them. Then whenever you are ready to complete that particular bug fix or that particular feature implementation, you stage it. So like I said, like I always say, we're trying to get you used to the concepts, because you may not even do this, you get, but I want you to understand, because you have to understand. That's where the DevOps, I will always repeat this thing. That is where the DevOps come, because in as much as you are not doing the work as a developer, you must or you should understand to a good level. Do you understand me? Please, can you unmute your mic and answer?
Yes.
Yes,
In
Yes,
as
I
much,
understand.
all right, good. So in as much as people are not doing developer, so that's why I'm taking my time to explain this to you in the most, in the simplest of ways, because you need to understand what the developer is doing before to be a good DevOps engineer, basically. So yeah. So for people that think that I'll answer your question when I'm done. So people that think that they have come to DevOps to avoid coding, you are right and you are wrong, because you may not write code. You will not even write code, or some environments where you will not write, but you need to understand to a good level. You don't need to understand 100% as per senior level, but you need to understand the fundamentals, which are all these. So yeah, Emmanuel, ask your question.
Okay, sorry. So I was going to ask about the stash, the stash. You said it's temporary storage. So I want to ask, how temporary is it? Is it like a RAM whereby when you kind
No,
of log
it's just
place
within
or
that process when you're working. So while you are on that project, while the project is on your laptop, that's temporary. Like, so for example, now I am working on a particular change, a particular branch, but they called me in to switch to a new branch and work on that particular new change for the next 5 hours. It will still, as far as that project is running as per your laptop, but it's not like permanent, because it's usually I call it temporary storage, because once you stage, the stash has gone, basically. You get. So it's just there waiting for you when you come back. Because the reason why Stash was created, because you cannot leave a particular branch without staging what you are working on. So that's why Stash is created. It's not staged, but it's stashed. I don't know the English if people understand that whole concept. It's not staged, but it's stashed. Until when you are done, then you not stage. Once you stage it, it disappears. You get.
Yes, sir. Yes, sir. Thanks, sir.
Okay. I feel like, I don't know, I'm getting some kind of code energy from the class. I feel like I'm trying to break it down, but I just feel like you are probably just hands on your head right now. And I'm sorry.
No, sir,
But the
sir, I'm
show,
actually following up, sir. Like the
the
last
okay.
explanation you gave now is just like someone trying to roof a building now. Now you have laid down your planks and your wood, but you have not put the pan on it. So you
Yeah.
want to attend to something else. You cannot say you are done roofing. You cannot call it
Yeah.
that you have completed your roofing. But
Yes,
you
exactly.
just put it there now to attend to something else, maybe
Yes.
work that was not finished or something. So at that
Exactly.
point,
Then
you cannot really call it roofing. And we are following up, sir.
yes. Thank you. God bless you, man. I like that. So yeah,
Sorry.
that's just it. Okay.
Yeah, sorry. In my own understanding, I think you meant stash as pause, then stage as complete and save. Is that
Yes, exactly.
okay?
Yes, that's
Okay.
just it. I like the fact that you are able to simplify it, because my efforts in simplifying it is making it sound complex, but I like the fact that at least it's okay. So yeah. Um, so next one. This is Git hooks. I don't know why I don't know why this is making that mistake. So yeah, these are Git hooks. So what Git hooks are basically, they are scripts that execute automatically when um when certain Git event occurs. They allow developers to automate tasks before or after Git actions. Before or after Git actions. Now, Git hooks are stored in the .git.hook repository, blah, blah, blah. Why use Git hooks? You get Git hooks enforce coding standards, which is run linters or formatters before committing code, prevent bad commits, automate testing, enhance collaboration. Now, what Git hooks does, it's an advanced concept, so we may not really go deep into it. But at least, like I said, I want everybody to understand it. What Git hook does is that there's sometimes when you need to create a particular sometimes when you need to create a particular script that will run, that should run before your your code is pushed to probably a branch or a repository. You need to create a particular thing that should run in between to help that push. That's what Git hook are. You may use it, you may not use it, but it's just good to know it. Because the truth is that I've not used it before. I've not found any need to use it yet. You get, but it's still fundamental knowledge. No knowledge is wasted in this game. Like I said, like you see all these setups now. You see pre-commit, which is a script that should run here. Pre-commit, prepare commit message, then it should now commit. So there are small scripts you can just use to automate some little things you get before you commit. Then if you want to push, if you want to also just set up a few things, everything is all about automation. But me, I've not really used it before, so I'm not gonna lie. But I just want, a situation where we know it so that you will not now be confused when you will get into any environment where they say, oh, implement Git hooks as part of your, process, and you will now start. I know that, yeah, people will say, oh, let's start. You can always Google and you can always search about it, but that extra knowledge at the back of your head, that extra knowledge at the back of your head is important. You get that external at the back of your head is important. Yeah. So let's go to the next one. There's work tree, allows you to work on multiple branches simultaneously without switching branches. This is almost a reverse of Git stash. The same thing you can all these ones are advanced concepts, like I said. Avoid frequent context switching, work on different branches, parallel development, fast code reviews. For example, if you have like multiple screens, or you can split your VS Code, your provider into like two different ways, two different screens, and you can work on this branch or work on this branch. It's possible, but it all ensures it's based on what you can do, basically. Yeah, but it's just like I said, good knowledge. Now, what is the remote repository? We have talked on, okay, most of the concepts that we're talking about. So, yeah, most of the concept we're talking about is, they're all just around the local repository environment and stuff. But now you're going to talk on the remote repository environment. Now, the remote repository is a version of your Git repository stored on a remote server. It allows multiple developers to collaborate, share code, and sync changes across different machines. Unlike a local repository, a remote repository is accessible via the internet or a private network. Key benefits of remote repository. Now, remote repository is basically what you have as GitHub. So it's like a version of your local repository on your laptop to a remote repository, which is GitHub. So most people are just familiar with pushing and pulling code from GitHub to your laptop, but you don't know the underlying concept, which is GitHub is your remote repository. You create a repository there, you push the code to that repository, and then if more people make changes to that code, they'll pull the code from that repository, basically. So yeah, GitHub repository. What is GitHub? GitHub is a cloud-based platform for version control and collaborative software development. It allows developers to store, manage, and share their Git repositories, provide powerful tools for collaboration, automation, and security in software development. Yeah, so at this point, we will go to a GitHub environment. So hands-on GitHub repository. So let me switch after. Please confirm you can see my screen. So yeah, I'm using my own GitHub as an example. Let me go over. Now this is once you log in, please can you mute your mic, please? Thank you. Yeah. Once you go in, you will see all the now this is my own profile. Basically all your projects are here, everything you want to work on. Now, if you want to create a new repository, we're not going to do that in this class. I just want to show you. You go to new, and then you create your repository name. You can search for anything. Now you have to ensure that this name has not been taken, because okay, it's not as if it must be taken or something, but it must not be a name that you've already used before. Now there's what they call a public repository and there's a private repository. Now, when you create a repository on a public repository, it means anybody on the internet can just search your repository and They can play with it or they can read it. They can read your code. They can read your code. They can change your code. They can even request, oh, probably you built like a notebook app, but you use blue color. They can help you and say, oh, sir, we want to implement pink color in your code. Can we do it? Then you approve. Once you approve, they will implement. That's what they call the collaboration. Once they will now get your code. And now exactly what I said before. They will now take your code, create a branch, do all the changes they need to change. Once they change, they will push the branch. Once they push the branch, it's you that owns the code now. Will now accept the branch and what? Merge to the main branch. That is what collaboration is. Now, it's in a public repository. When it is now public, meaning that everybody on the internet can collaborate with your code. A guy from India now can just like my code and be like, oh, I want to make a particular change I want to add to your code. And he does that whole step of, creating a branch and the rest. It must not necessarily be when there are errors or something, but that's basically just what the whole Git and GitHub environment does. You get? Now, that's just what it does. Now, private repository, on the other hand, is for when you are within an organization. For example, your code has sensitive data, and it's only developers in the company that should have access to that code base. That's when you use private repository. And this private repository usually works well when it's within an organization. So GitHub, they have what they call an organization, where when you create an organization, the organization is most likely your company, like where you work. Once you get a job, you add it to the organization. Once you have your GitHub account, you add it to the organization. And you would basically be added to it. Now you will see all their private repositories. Now, private repositories are embedded within the organization, and it's not accessible only when you are invited into the organization. No outsider can come and collaborate on your code or anything. Now, there's also a README file. Now, this README file is a documentation. This is where you can write a long description for your project. Now, this is the place where if I bring a project, now someone wants to come and read about the project, they will come to this README file. This is what I put in the tags for those that have seen it. You create a README file, and then you write every description that you need to write concerning your project. For example, oh, this is a web-based app that I'm used to book taxis online. This is a mobile app that I use to order food. This is a mobile app that users can use to pay their school fees online. It is in the README file that you write all those stuff. Now, a git ignore is if you have specific files that you don't want to be committed from your local repository to your remote repository. If you have a specific files that you don't want to be committed from your local repository to your remote repository, that is where you use git ignore for. So you put it most times. There are some modules that are very, very heavy that are just used to run the code locally on your laptop, but you don't want them to push it to repository. You add a git ignore file. We'll talk about that one when we do the hands-on. Then there's a license. So this license now, it is a license. A license tells others what they can and can't do with your code. So there are a lot of licenses here. I won't go through them, but the most popular one is the MIT license and the Mozilla public license. So these two licenses are the license that for example, if you're having a public repository that you want other people outsiders to commit to your code, these are the two licenses that the most. You can go and do a research on the most, but this is the ones I use, Mozilla and MIT. There are some licenses that are specifically that specifically guards the code, that nobody can replicate it. Nobody can, like, if you add this license to your code, they'll have to bring lawyers to be able to collaborate in your code. But these are the two I use basically because most of the code I've written, most of the work I've done basically is just public, except it is within the company. Yeah, so when it's within the company, most time when I'm within the company, they use the BSD license, but I'm usually not the one that sets that up. But yeah, basically. So this is now once you do all this, you create the repository. Now, for those of you that are going to use the public, for those of you that are going to do the tax first, before we go hands-on, this is how you create a GitHub repo. You set everything up, you add the README, and you create the repository. You may choose to add the README from here, or you may create a repository like that. Then add the README from your code base, from your local repository, and push it, which is what we will learn next week. So, this is probably just the end. There's no other thing I will need to show you here. This is basically everything you need to know concerning this theoretical point. Now this my profile is public, you can go check it out. You can use it as a guide to setting up your own. Surely for those who don't have GitHub libraries, you need this because if you join a company, they'll ask you for a GitHub repository to be able to add you to the organization where you get your work done. So yeah. So I think I will stop sharing now. Any question? Who's saying brilliant students? Please, is there anybody that has anything to ask? Can we use the three? Yes, I'm saying,
Good
can
evening.
we use the three? Can we use, hold on, please. Someone's asking, can we use the three, Git stash, Git branch, and Git? Yes, you can use it. You can use all of them, but it depends on the complexity of the project. You get, because one thing about Git, basically, Git is like a dog leash, or it's like a leash, or it's like a rope. It's like a rope, basically. If you if you bend it anyhow, it will tie your leg and you will fall. So you have to be very careful of the way you have to be very careful of the way you know the way you structure, the way you attend to things. Like I said, it's like a rope. If you tie it anyhow on your this thing, and when you want to pull it, when you want to push your code, just tell you this code cannot be pushed. XYZ has occurred on your Git on a local repository. Please check it. So yeah, you have to be very careful. So that's why I'm providing the fundamental concepts now. So yeah, any more questions? Alphonsus, good evening.
Good evening, sir. Good
Good
evening,
evening.
everyone.
Good
Sir,
evening.
please, my question is, sometimes when you're on the theoretical part like this, it looks as if everyone is understanding till it gets to doing the tax itself. So
Yeah.
I don't know. So am I too fast by asking, is it not yet time for us to like install or download the Git or the GitHub itself so that some certain things which like the illustrations you were doing there, you can now say this how you do this how you do this, or are we still
GitHub.
waiting till
That's
the
what
next
I said
class?
now. That's what I said. The theoretical part, I would in the tags there is a video and there are I don't know if I set it up, but I will check it after the class. But there's a particular video, a particular resource I would say to install Git. You have to install the Git on your laptop to be able to use it. For those that are using Windows, Mac, or Linux, you install the Git and create your own profile, which is your username and email on your Git profile. Then that's where you can do that. I would let me see. But that's just it basically. You have to regarding I just said the README file. I just showed you how to set up the README file. So the README file, what you do is once you create the README file, then you write on it. You write basically what I send in the tags on it. That's just it. I've literally showed you how to set up the GitHub with the README file. So yeah, basically. So Alphonsus, what? Yeah, you are writing on it. You're not writing code. You just write. So how the task is set up is after creating a GitHub, creating your repository, you create the README file, and then you will write a summary of the last class. It's basically the summary of the last class. If you go through the task, you see it. The task is not formatted properly. I don't know why. From the LMS. I don't know why it's like that. But what you just do is you can go and watch the video from the last class, and then the summary of the video is what you put there, and then you commit it basically. So that's why I want to do a hands-on, because it's like something I can finish in like 20 minutes. But I want you to understand the concept so that when you're doing it, you would get the feel of it. So yeah, questions, Emmanuel.
Yes, sir. Thank you, sir. I just check my LMS. I can't see any task
Can
on
you
there
log in and
yet.
log out and log in? I've already uploaded it. Some people have even done it self and have marked it. That's the
Wow.
people
Okay.
that
So,
the people that know the stuff. So so that's just it. I'm telling
okay.
you,
Then
and I was
also,
surprised in like 1 hour, like 3 submissions in like 1 hour after I uploaded that. So yeah.
so today's class is not inclusive, like in
Yeah.
the README. I will not like today's
No,
class
it's
won't
not
be
today's class is
inclusive.
not included. Today's class is today. The task came this afternoon. The task came this afternoon around 1, 2. And I wrote it on the Discord channel. And some people have submitted and I've marked them.
Okay, my other question is that I don't know how you did the new repository while you were like sharing your this thing on your elements. I don't know how you did that new repository. I did not get
Oh boy.
that.
Okay, I don't know if I can share my screen
Thank you.
again. Hold on. Please, can you see my screen? Hello,
Yes,
please
sir. Yes,
confirm you
sir.
can see my
Yes,
screen.
yes, sir.
Good. So, see this button here, new. Are you seeing it?
Okay.
Good.
Okay.
Once you click on it, it takes you here and you do all the create new repository and everything. Then you create a repository. So in the next class, I would show you, I will give you like a rundown on, I'll just basically run through I won't run through a lot of the advanced, but I'll run through the basic ones like the commit, the stash and everything, and branching and all those basics. Then we will now set up a new repository and show you how to push code basically. You may, like I said, you may not necessarily be pushing. You will push code to a good extent, but you're not something that you'll be doing in your day-to-day routine. But like I said, like I always say, you need to learn it. These are developer knowledge. This is why it's called DevOps. See, people always think, oh, I'm coming to DevOps, I will not write code. You have to understand the code. That's the dev. The ops, you have to understand the operations. That's it, basically. It's not easy, to be honest. It's not going to be easy because you're literally learning 2 fields at once. But it's doable. I'm a living testimony. So yeah, you're shocked by this tax. What is shocking you, bros? So please, can someone drop on the group? It was uploaded this afternoon. And I'm sure that some people have done it. I'm telling you that some people have done it because I've marked 2. I'll be 3 this afternoon.
Maybe those that have not seen it should try to log out and log in. That was the same thing
Yeah,
I
if
did.
you try, if you can't, if you're not seeing it, log out and log in.
That was the same thing I did. And I just refresh.
Yeah, so someone should drop on the group after the call on the Discord channel so that I will send you a link on how to set up your Git. Please try and set up your Git within the next 24 hours and play around with the ones you can play around with. You can read through all the commands I've talked about in the video. You can create a folder, even as much as there's no code in the folder. Just create the folder, create the text inside the folder, and then just figure out how to just play around with the commands a bit. You may make mistakes. As I say, create a folder, a very, very non-sensitive folder, and just play around, can watch videos and stuff. But I'll share you a resource where you can use to set up Git. Yeah, so now when we come on Friday, we'll talk about the whole the meat of the matter, basically. So yeah, any more questions? I want to log off.
Yeah, please.
Okay.
The previous classes, please. I can't seem to find them. The first class, the second class. This is the third
On
class.
YouTube.
Okay, they are on YouTube.
Okay, the class, they are on YouTube. They are on KodeCamp YouTube channel. The classes are uploaded immediately. As I'm talking to you now, next 1 hour, this one will be uploaded on YouTube.
Oh, okay. All right. Thank you.
Okay. I can also provide a link as well to that if you want.
Okay, thank you.
Yeah, KodeCamp. Someone even said the KodeCamp on YouTube.
All right, thank you.
So before midnight, it will be uploaded.
All right, thank you.
Yeah, just go to the DevOps playlist and you'll see, because there are a lot of other classes, for the UI, UX, and all of them.
All right, thank you.
Yeah, no problem, boss.
Sir,
Alphonsus,
please,
yeah.
sir, I just logged out and logged in. Oh, my own is still not showing me the tax, but my profile is displaying very well. But if I go to the tax,
It's probably not from my end. I'll figure out. I'll ask the admin for the issue.
okay, it will just be
Please,
showing me
Ajibola, can you
join
unmute
the
your mic,
Discord.
please?
It will be showing me join the Discord channel. Join.
So yeah, that's the problem. Now, click on all those things. Click on them as per you have done them. Those are onboarding screens. Click on done. I'll be whatever you're saying there.
Yes.
Then you
Okay, sir.
see
My last
mark all
question
as
is
done. You see
okay.
mark all as done. Click on it. Then you will see the
It's not
tags.
clicking.
Then
The mark all is not clicking from my end, but I will still do that again.
see, wait. Let me explain. Calm down. You will see 3 tables. 3 cards. Click
Yes, sir.
on done. Done for the 3 of them.
Okay, sir.
Have you clicked on it for the 3
Yes.
of them? Then you will
Yes.
see mark all as done. It's still not clicking.
Let me click on the mark all. Okay, yes. It's
Have you
showing blue
clicked?
now. It's showing blue now, but it's not clicking.
Click on it now. It's not clicking.
It's loading. Let me see if it works.
If it in loads, then you take it and you go to the tags and you check see the
Okay.
tags.
Okay, sir. Thank you, sir.
Have you seen it?
It has taken me down there now, sir.
Okay, good.
Thank you
Elijah,
so much.
good evening.
Good evening, sir.
Good evening.
For those that have Git already on their laptop, they will not do the Git
You won't do
setup
the
again.
setup now. You just go straight to the tags. I just want to send the links for those that don't have, so they will install it.
All right, thank you.
Thank you. So yeah, okay. I feel like everybody is done. That being said, thank you very much. So what have we installed? You're installing Git. We're installing Git. I'll send you a link. Install Git. So yeah, that's been all right. No problem.